Let's go to page 51 and section 5.1. This lesson is on divisibility. Okay, so start with 1. Every number is divisible by 1, so obviously 1 is very obvious. Now, divisible by 2. Okay, so this one you look at the last digit. So if the last digit is divisible by 2, then it's divisible by 2. So that means it has to be an even number. Okay, now divisible, since I'm talking about 2, I'm going to just go by exponent of 2. So to test divisible by 4, okay, so since 4 is equal, so 4 equal to 2 squared, so this is 2 to the 1 power. So you look at one last digit, okay? Now this is 2 to the second power, so you look at the last 2 digits. The last 2 digits have to be able to divide by 4. Okay, so example of that would be, for example, if you look at like 24, okay, or like so it doesn't matter what digits over here. You can have any digits, or you have to look at the last 2 digits. So if last 2 digits can divide by 4, then it's divisible by 4. Then the next one is divisible by 8. Okay, so 8 equal to 2 to the 3 power. So you look at the last 3 digits. The last digit are able to divide by 8. Okay, so you can have all sort of digits as long as the last 3 digits like 0, 0, 8. Then this is divisible by 8. So it doesn't matter what digits are out here. So look at the last 3 digits. So you keep going the pattern. So divisible by 16. Since 16 equal to 2 to the 4th power, you look at the last 4 digits. They're able to divide by 16. So again, it doesn't matter doesn't matter what digits are over here, as long as the last 4 digits can divide by 16. So it would be like 0016, for example. So it doesn't matter what digits are out here, or 0032. Okay, so all this would be divisible by 16. Okay, so now we're done with the 2, 4, 8, and 16. Now let's go back to continue with that. So divisible by 3. Okay, you have to add all digits together. So sum of digits is able to divisible by 3. So example would be like one of the easy example, 1, 2, 3. Okay, 123. If you add a digit is 6. 6 is divisible by 3. So this is divisible by 3. Okay, so we did 4. Then we go to the 5. Divisible by 5. The last digit. The last digit is either 0 or 5. Okay, so this is kind of easy. Now to divisible by 6, since 6 is equal to 2 times 3, okay, so that means the last, so you have to fulfill the 2 and the 3. Okay, so you have to be able to divide by 2 and divide by 3. That means the last digit is even, and the sum of digit, okay, sum of the digits is able to divide by 3. Okay. Now divisible by 7, there's a way to do it, but it's not advantageous. So you just go and just divide whatever the number is. You just divide by 7. Okay. There's a way to test, but it's not too much advantage. Okay. For example, let's say if you have 370069. To test if it divides by 7, okay, you can do it this way, just divide by 7, or what you do is you multiply the last digit by 2 and cross it out. So 9, you multiply by 2, you get 18, you put over here, and you subtract. Okay, so you're going to get 36988. So you get last digit, you multiply by 2, so you get 16, and you cross it out, okay, and you subtract. So you got 3682. And cross it out again. Last digit, multiply by 2 and cross it out, and you subtract. So you keep going until you see that the number you have, if it's a multiple of 7, then it's divisible by 7. If it's not a multiple of 7, then it's not divisible by 7. So you subtract. Okay. Again, last digit multiply by 2 and cross it out. Now, as soon as you get here, okay, you know that 28 is multiple of 7, so you know that this is divisible by 7. Okay, so this is one technique, but this does not really save you time. You can just do it this way. So either method. Okay. Okay, so we already did the we already did the 8. So let's go to 9. So divisibility by 9, that means the sum of the digits have to able to divide by 9. Okay. So example, that would be, let's say, like 6 to 1. Okay. So 621, if you add digits together, then it's equal to 9, so it's divisible by 9. Okay. Divisible by 10 is easy, the last digit equal to 0. Okay. Now divisible by 11, okay, so let's use an example. So it's kind of a bit hard to explain. So let's say if you have 4, 6, 8, 3, 8. Okay, so what you do is you sum up the alternate digits. Okay, so like this will give you 20, and this will give you 9. Then you take the difference. So if the difference of the two numbers is multiple 11, then this is divisible by 11. So you can see that the sum of the alternate digits is 20, and this is 9. The difference is 11. So this is yes. This is divisible by 11. Okay. So that's how you test for 11. Now divisibility by 12. Okay. So this 12. So 12 is equal to 4 times 3. Okay. So you have to fulfill the 4 and the 3. That means, so from here, so it means the last two digits have to able to divide by 4. So last two digits, right? And the sum of digits is able to divide by 3. Okay, so that's how you do the 12. Divisible by 13, this one, don't know, don't have any information. Okay. And divisible by 14, since 14 is equal to 2 times 7. Okay, so that means the last digit is even, and you have to be able to divide by 7. Okay. And divisible by 15. Okay, so 15 is equal to 3 times 5. That means the last digit is either 0 or 5, and sum of digits is sum of the digits able to divide by 3. Okay, and we already did a 16, and so that's as far as it's going to go, up to 16. So we can test the divisibility from 1 through 16, with the exception of 13. Okay, I don't know, it's a way to test it easily.